right, so subpart 2, you start being able to use the calculator. And number 11 tells you the fourth term in a sequence is 108, and each term after the first is 3 times the previous. So I'm going to just set this up. So first, second, third, fourth is 108. Now, there are formulas we could use to do this, but I'm just going to think logically, think backwards. So for if we have 108 and we want to find the previous term, we're going to, instead of multiplying by 3, we're going to divide by 3. So that's 36. All right, and then we'll divide by 3 again. And that's 12. And then we'll divide by 3 one more time, and that should give us the first term, which is 4. All right, and then number 12, we have this quadratic equation, and we want the solutions to the equation. And so you can tell by looking at all of those that you get imaginary solutions. So this is one that we're probably going to need to do the quadratic formula. Okay, now some people, I help them with this specific question because they tried to type the whole square root in their calculator, but you just type what's under the square root. You don't do the square root. So in the calculator, we would do 4 squared minus 4 times 3 times 8. And that means we're going to get negative 80 underneath the square root. So we will definitely pull out an I. And then we need to find the largest square that goes into 80. And it's a good idea to use your resources. We can use our answer choices. All of us have a 5. Now 5 is not a perfect square. That's why it's still under the root. But I can take 80 and divide it by 5, and that should give me a perfect square. And it does. It gives me 16. So I can break 80 down into the square root of 16 times the square root of 5, and the square root of 16 is 4. So the 4 breaks out of the radical present. Now that is not the answer, an answer choice, because I can still reduce. So I would draw the heart. And I would reduce each of those by a common factor of 2. And that matches up with S. Okay. Number 13 has 2 parts. The first part is to graph the system of equations. And so we are going to do that using the calculator. So we'll go to y equals and type both of these in. All right, I'm just going to go ahead. I'm going to do them one at a time. So let's get the table. All right, that's actually a really good table for this parabola because I can tell my vertex is in the middle. That was just a coincidence. And so I know that because the top and bottom are both -4, and then as we go in, they're the same and they're the same. So I'm going to graph those ordered pairs. I'm having a hard time remembering what they were. 3, 5, 2, 4, and 4, 4. 1, 1, and 5, 1. Okay, so there's my parabola. Now, if they have you graph a parabola using the computer on the Chromebook, good luck. I'm not sure how that's going to work. Crossing my fingers I don't have you do that. Okay, and then the other one is going to be absolute value graph. And so to get absolute value, we're going to do alpha window number 1. Okay, we have to be careful on this. So this is also set up pretty good for the absolute value graph. So we're just going to ignore this middle row or column. And so we're going to graph the point 0, 2, 1, 1, 2, 0. Oops. I went down too low. Okay, so that's why it should look like a V graph and an absolute and a parabola. And then part B asks us to find all the values for x, or just the x, where those two are equal. So the values of x where those two are equal are going to be this point and this point is where they intersect. So that's x equals 1 and x equals 5. Or you could just put 1 and 5 in that box. Okay. Number 14 is pretty tough. So a person's batting average is determined by dividing the number of hits by the number of at-bats. William has 11 hits, 53 at-bats, and has a batting average of 208. He wants to have a batting average of at least 300. Which equation would or could be used to determine X, the number of hits in a row William needs to get in order to have a batting average of at least 300? Okay, so they all have the 300 less than. So the thing that's the bigger one is the batting average. And so that X needs to be added to the number of hits and needs to be added to the total number of at-bats, which is going to be the answer D. All right, and then part B says how many hits in a row after the first 53 times at bat would William have to hit in order to get a batting average of exactly 300? So what we would do is just change that inequality we chose for D to an equal sign and solve it for X by multiplying by this denominator Oh, that should be 0.300. Sorry. All right, so then I will distribute that 0.300 and then get the x's together. By subtracting 0.3 and then subtract 11 and then divide by 0.7, and that's going to be 7 hits in a row. That's pretty hard to do. Okay, number 15, I haven't taught you how to do it, and I'm sorry. If they put this one on there, we would need a lot of days to learn a lot of different things to get this question right. The answer to this is P. If we get out of quadrant one thing just to narrow it down, if you get out of quadrant 1, like third quadrant, if one of these is positive, then the other ones are going to be negative. That might help you narrow it down. I'm sorry. I don't want to waste your time on that question because we literally would have to spend a week learning that to be able to get that question right. Okay, let's look at 16. 16 is kind of a weird question, but it's doable. So they give you this identity that is for solving the difference of squares or factoring the difference of squares, and they're going to ask you to kind of use it to determine the value of 52 times 48. And so what we are looking for is that you could do x plus y, this part right here, and get the 52, and do x minus y, this part right here, and get 48. All right, so those two numbers that are going to add to give you 52 and subtract to give you 48, sorry, are going to be 50 and 2. So that's one you can kind of logic through. All right, for 17, a researcher wants to determine if the behavior of children is affected by playing video games that have violent content. He asked parents of 100 children in a daycare center how often they play video games and whether the video games have violent content. The children are then allowed to play in a controlled environment, such as the daycare center playground, and any violent behaviors are then noted. So this is an observational study because they don't make any changes to their behavior or what they're doing, and they just do what they always do, and they're observed, which is observational study. All right, and then 18, you are given two different functions, so be careful. We're given f of x, and we're given h of x. All right, and so the question is comparing their y-intercepts. So to get the y-intercept of f of x, we're going to type it in the calculator and just look at the graph. So there it is. Looks like the y-intercept is up at 6. So you can count the little tick marks. So that one has a y-intercept of 6. Okay, and then on the table, the y-intercept is also on the graph too, is when x is 0. So the y-intercept of the table is negative 6. So if we're comparing them, how many units above the h-intercept is the f-intercept? So between 6 and negative 6 is 12 units. All right, for 19, a survey asked 410 students whether they would eat food served in the school cafeteria, and the results are shown on the table. What is the probability that a student will not eat food given that the student is in the 10th grade? So the only people we care about in this table right now are the 10th graders. All right, and that is going to be a total of 110 10th graders. And so the question is, what's the probability that they would not? So there's 47 no's out of 110. Now don't put that in the answer choice because it says that we want it rounded to the nearest hundredth. So what you would do is type in the calculator 47 divided by 110. All right, and then to the nearest hundredth is the 2 is in the hundredths place. We look behind it, so we're going to round up to 0.43 or 43 hundredths. All right, number 20. A rock is dropped from a hot air balloon at a height of 100 meters. The rock's height from the ground in meters. The rock's height from the ground in meters, h of t, is modeled by that formula where t is time in seconds. What is the average rate of change of the height of the object between 2 and 4 seconds? So we haven't talked a ton about average rate of change in a long time. It's basically the slope formula. All right, so this is x1 and this is x2. To find y1 and y2, you're going to plug them into the formula. Okay, and when I did that earlier, just in the calculator, I got 80.4. So that means at 2 seconds, the rock is 80.4 meters above the ground. And then we need to figure out h of 4. Those are our special x's for this problem. Then at 4 seconds, the rock is 21.6 meters above the ground. So our average rate of change, this is y2, this is y1. So we'll do 21.6 minus 80.4 over 4 minus 2. Be careful you keep it in order. So I plugged in 4 and I got the 20.1, so they should be lined up vertically. I plugged in 2 and I got the 80.4, so they should be lined up vertically. Okay, I'm going to use the alpha y equals fraction bar, number 1. All right, that gives us negative 29.4, which is answer C. So don't forget, when you do average rate of change, that just means the slope formula from back in algebra.